Hello everybody, myself Jyoti and this is first lecture on field effect transistors. Basically let us try to understand what is ordinary transistor or why we call ordinary transistor as a bipolar transistor. So when we talk about ordinary transistor, in that both holes and electrons they take part in the conduction process, and for this reason it is sometimes called as a bipolar transistor. But the disadvantage with the ordinary transistor is it has very low input impedance. Now this low input impedance, it is because we have emitter base junction forward bias. So we know that when it is forward bias, naturally the resistance will be low. So that is how it has low input impedance. And second disadvantage with ordinary transistor is it has considerable noise level, and that is how we shift to another transistor, that is field effect transistor. Now, when we are talking about the problem of ordinary transistor having low input impedance, we can solve that problem. Maybe by improving the design of that particular ordinary transistor and by using more than one transistor. But still, it is very difficult to achieve input impedance more than few mega ohms. When we talk about field effect transistor, uh, by virtue of its construction and the biasing which it has, thereby it provides large input impedance, and this large input impedance it is of the order of 100 mega ohms or more than that. And the fate is generally having very less noise level as compared to ordinary or bipolar transistor, and this is the reason why we choose field effect transistor over ordinary transistor. Now, in case of a bipolar junction transistor or BJT, it is a current controlled device. That is, when we plot the output characteristics of BJT, they are controlled by base current and not by the base voltage. But when we talk about field effect transistor, the output characteristics are controlled by input voltage and not by input current. So we call BJT as a current control device and FET as a voltage control device, and this is the biggest difference between BJT and FET. Now there are two types of field effect transistors. One is JFET, that is junction field effect transistor, and second one is MOSFET, that is metal oxide field effect transistor. Now what is JFET? So a junction field effect transistor, it is a three terminal device. It is a semiconductor device, and the current conduction in this device it is by one type of charge carrier. So either electrons they take part in the conduction process or holes they take part in the conduction process. That is how it is also called as a unipolar device. JFET was developed about the same time as that of transistor, but it came into the general use only in the late 1960s. In a JFET, the current conduction is either by electrons or by holes, and it is controlled by means of applied electric field between the gate electrode and the conducting channel of the device, which we will see later on. So the JFET has high input impedance and low noise level. Now let us see the constructional details. So here you can see, so when we talk about the construction of JFET, it is either a N channel JFET or a P channel JFET. So if you look at the N channel JFET, the rectangular portion which you are able to see here, that is a N type silicon bar. So basically we take N type silicon bar, and on either side of it you can see P junctions are made, and these P junctions on either sides they are connected internally, and one of the terminal is taken out from that, so that is gate. And on either side of the silicon bar we have drain and source. Now when this silicon bar it is of N type, we call it as a N channel JFET. We can have a P channel JFET where the silicon bar it is made up of it is a P type, and then on either side of it you will have a N type junction. So this is the basic constructional detail of a JFET. So JFET consists of a P-type or N-type silicon bar containing two PN junctions at the sides. The bar forms the conducting channel for the charge carriers. It can be called as a A-channel JFET or P-channel JFET depending upon which type of bar it is used. If the bar used is N-type, it is N-channel JFET. If it is used as a P-type, it is P-channel JFET. And the two PN junctions which are formed on either side which are diodes basically, they are connected internally and one of the terminal is taken out from it, that is gate. And the other terminals which are there, source and drain, they are interchangeable. So you can make one source, one drain, or drain and source, either way. JFET has essentially three terminals: source, drain, and gate. Now let us talk about the JFET polarities. In P channel JFET or N channel JFET, the voltage between gate and source, it is such that gate is reverse biased. Now when we are talking about reverse bias, we know that reverse bias may input impedance, it will be high, and that is the reason here we have high input impedance, which is the advantage as compared to ordinary transistor. And this is the normal way of JFET operation, JFET connection, that the input junction, it is always reverse biased. The drain and source terminals are interchangeable and either end can be used as a source or as a drain. So look at this diagram. You can see the N channel JFET and P channel JFET, and you can just check this polarity VGS. So you can see that when you are having a P type junction here, I've connected the VGS in such a way that negative terminal of it is connected to P. That means it is reverse bias. And look at the other diagram. You can see here N junction is here. So I have connected the VGS in such a way that positive terminal is connected to N. So again, it is reverse bias. So whenever you are connecting JFET, for normal connection of a JFET or normal operation of a JFET, the connection is the gate to source junction, it is reverse biased. So the points to remember is the input circuit of JFET is reverse biased. That is what the advantage of JFET is over ordinary transistors. So always remember the input circuit of JFET is reverse biased. This means that the device has high input impedance, and the drain is so biased with respect to source that drain current flows from the source to the drain. And third point, in all JFETs, source current is, it is equals to drain current. So these are the 3 points which you have to remember. In the later lecture, we will talk about working of JFET and all. So thank you so much.